Hello everyone, how is it going? We are here to start a new series in this channel. This is about mathematics for machine learning, as this channel is dedicated to machine learning, software development, software engineering, and many things related to it. And we are going to study all the mathematics we need for machine learning. We'll be covering here all the linear algebra, and we'll be doing calculus, and we will be doing statistics, probability, and we will start from the foundations. We will no prior requirement is there, no prerequisites for this course, and we are starting from introduction, why we need maths in this software world. So let's start. I would like to start with the quotation by Galileo. Mathematics is the language in which universe is written. So mathematics is I would like to use mathematics as a poem for a scientific discovery, and math is taking strong part in machine learning, data science, and all software development. So in softwares, mathematics is there under the hood, and let's talk about abstraction. Whatever we create, we have created in this current era. We can take example by a fire, which we, as a human being, we started with rubbing the two stones and to create a fire. Now if we want to want a fire, then we do not go to the stones and start rubbing them. Rather, these things are in abstractions. So we use a lighter to burn or to create fire. So there's all these layers. There may be a torch in the middle. There may be some ways to create fire. Now it is all synthesized and it is all abstracted, and now we use lighter to burn or create fire. So in the same way, in the software, what all the tools and all the frameworks and all the libraries, they created abstraction. And so if we need to build a software, or if we need to do anything, so we don't start with the foundations. We start what are the tools available, and we start from there. So moving on, the big question: do we still need math? So in few past couple of years, uh, as machine learning has done a significant improvement, especially in generative fields, which is a sub part of deep learning, and which is a big domain containing inside machine learning. So everyone is excited about it and wanted to know more, and whoever choose machine learning as their career path, mathematics is one of the key things you can't avoid. You need to uh, you need to be able to communicate in maths to have a good model and to create a good model. So yeah, software feels magical. Yeah, earlier I talked about software feel magical, and we can create anything using softwares, and we need to look under the hood what is going on inside. But in the bigger context, do we need mathematics? And if you are in machine learning, data science, and some also game development also needs maths. So if these are your domains, then you need maths. uh, this is a no-brainer because uh, I'm coming there how we need maths. So hidden reality, let me give you an example. This for example, this is a model for predicting weather. All right. So it was doing great until what happened is this model was created in summer, and now it is winter. So by some reasons, this model is not effective in winter. So what we got to do is we have to check uh, the accuracy of this model. So, and what are the reasons, whether it may be the weight or parameters that are or data that are the reasons for failure of this model in winter season. So that is the reason, if we don't know any maths, then we cannot take our equations, take our models in these format and tweak them. Like I need I need to have more this or more that. That is the reason for tweaking a model in the background, or for making a changes in the background. So we need maths. That is an inevitable question. So in mathematics, there are especially three main domains that machine learning picks its flowers for its basket here. So linear algebra. So it is a this is everyone knows, this is the basic equation of slope. So linear is a straight line, and this is the equation of linear. So later on, when we get to there, when there is lots of vectors and matrices, and these all have data represented, and we are going have we can have a dot product, a cross product. uh, so to have intuition, to have an hypothesis, so there, um, the linear algebra plays a vital role. And for calculus and learning optimization, so calculus is simply calculus. What it does is it fine tunes our model. It checks is the model accurate or not. It can create a simulation, and it can find the accuracy of model beforehand. And same way with statics and uncertainty prediction, and there are different probability things are here. We need to know there are different naive-Bayes theorem, and different classification, clustering. So to visualize what the model can do, or what model has done, we use stats and probability, and and we can create an algorithm using these models, and we learn from the algorithms that are previously provided to us, or we have studied about different kind of algorithms are there. There are Bayesian theorem, and different search engine algorithm like BM25, and there are lots and lots of algorithms, and we need to study about them to have our model to have higher accuracy in our model. And it matters to understand the algorithm behavior and debug intelligently. And yeah, calculus comes to play here, and design smarter models. So whatever we see, LLM is large language models. So this is a product of a machine learning, because machine learning creates a model. So it has all these vector cross product, dot product working in the background, and all the things are going to happening inside. And we see different rankings of LLMs. So that are all because of fine tuning and algorithm understanding they do, engineers and researchers do in the background, and to make the model more accurate and more faster. um, so let's move on. And uh, code software engineering is basically abstracted into coding in this current time, because software engineering has strict principles and strict frameworks we need to follow to build a working software. And math is a reasoning, like math. I would like to think of a math is something that we can debate upon, and uh, by our intuition, mathematical thesis, we can reason for better, and we can give our context and how this model is better than other. So moving on, thinking advantage, math builds logical clarity, pattern recognition, and structure thinking, problem solving discipline. So whenever math is there, uh, it has a problem solving approach. In this universe, AI is basically artificial intelligence, and it is mimicking from human intelligence using mathematics. Uh, we can see in the universe, we can see eye. Whatever the eye sees, it captures and it uses. It has, sorry for the drawing, I'm not good at drawing things, but let me try again. This is the human vision. Uh, this is what human sees. Okay. And now, in the other hand, I would like to add a product of artificial intelligence, that is a robot. Okay. So, whatever human sees, it has its memory, that is hippocampus in his brain, and it whatever information comes, it goes in here. It's like whatever it sees, it goes in here. But what happens is, whatever a robot sees, For it to remember it, it needs to vectorize and create a pattern from seeing. It cannot see like a human. It sees in such a way that everything is mathematical. When it comes down, whatever it sees, it will calculate the data. It will create the data points and different dimensions, and it and it creates a pattern. It creates a model, and if it is a general purpose robot, then it stores whatever it needs in its memory. So AI basically can be also defined as natural mathematics. I don't know, whatever. So moving on, let's go to next. Real world powers. AI is used in fraud detection and predictive analytics, decision automation, and builders mindset without maths tool operators. Uh, and that is why it is it is a crucial thing to learn math. So don't worry about anything. We don't need to learn anything to get started. I am teaching from school level to all the necessary things, just all the necessary things, the right amount of things to get started to for machine learning. So thank you very much for staying with me, and a lot more series are coming. Exciting new series are there with all the mathematical jargons, and later I'll be covering up programming languages and all the things I need for machine learning and data science. So thank you.